So you can hear me that side, eh? On Zoom.
Yeah.
On Zoom, eh?
Yes.
Okay. So we're looking at network topology. Network topology means the way computers and devices are arranged on a computer network. Arranged or organized. You can say arranged or organized. You may have you may have computers, maybe you may have a fixed number of computers, but you can arrange them differently on a computer network. The way you connect them can be different. We have what's called a bus topology. Bus topology is where computers are connected to one main cable. For example, here we have our computers and devices. We have 1, 2, 3, 4. We have 4 computers, but we also have 2 devices. This one and this other one, which might be a computer also or a device. I'm not so sure. But all together on this network, they are how many devices and computers? 1, 2, 3, 4, 5, 6. They're all using the network. But in this case, they're connected to one main cable. So this main cable, this is where all data passes when it's being sent from one computer to another. For example, if this computer here wants to send data to the printer, which is down here, this computer will put its data here on this cable, on this main cable. Then that data will move through this main cable, and then the printer will pick it from that cable. The computers and devices don't communicate directly. What do I mean? If this computer wants to send data to this printer, this computer cannot send data straight to this printer. No, it must put it on the main cable. So the purpose of the main cable is to transmit data. Transmit data. So it can be picked or received by other computers. This is called the bus topology, where computers and devices are connected to one main cable and all data passes through that main cable when data is moving from one computer to another. However, one other thing about the bus topology is that if this computer wants to print, it will put its data on the main cable. When this computer puts its data on this main cable, these other computers cannot put any other data. Why? Because this main cable is being used by this computer already. What does that mean? That means that only one computer is allowed to communicate on the network. Only one computer is allowed to communicate on the network. So let's take a scenario whereby all the computers have work to print. This one, this one, this one, and this one. They have work to print and they want to send it to this printer. These computers cannot put all their data at once on this cable, no. If this computer puts its data, these ones have to wait until when the data for this computer has reached the printer. Then this one, if it puts its data here, send it to the printer, these ones cannot communicate, cannot put any other data to communicate their data, no. They have to wait. So only one computer uses network at a time. That is one fact about the bus topology, which is also a disadvantage for it. So what are the advantages and disadvantages? Obviously, one disadvantage we said, only one computer uses the network at a time. Let's write it here. Only one computer is allowed to communicate on a network at a time. I get me? Only one computer is allowed to communicate on the network on the network at a specific specific time. What does that mean? Hence, if a computer communicates something on the network, then the other computers cannot communicate until the first computer has finished communicating. So that's one disadvantage for the bus topology. What does that mean? How is a disadvantage? It means that what? Network is what? Is slow. Network works slowly. So the bus topology works slowly. Or you can say communication is slow. Because only one computer is allowed to communicate at a time. At the time. Now, next, it's very clear here that if the main cable breaks down, the network cannot work. So the network cannot work if the main cable gets spoiled or breaks down. Network cannot work. Why? Because data will not be transmitted. Because data will not be transmitted between the computers. See? This is one problem. If this cable gets spoiled, that means the computers can't communicate or cannot send data to one another. Because we said all data must pass through the main cable. That's one other challenge. Another disadvantage is that it's expensive because it uses many cables, obviously. The cables are quite many, so using cables becomes what? Expensive. Then also using many cables means that the network will be inconveniencing. But we shall look at that later. Advantages for bus topology. It's very clear here. If one computer fails to work, the network still works. Then it is very easy to connect computers and devices to the network. That is true. It is very easy to disconnect and remove computers, disconnect or remove computers and devices from the network. That is very what? That is very easy because you just remove it from here. Just if you remove this one, the network will still work. So you just remove it without any fears or without any great what? Challenges. We have what called a star topology. Now, with the star topology, it works differently. The connections are different. Here we said in bus, all computers are connected to one main cable. Let me try to divide this screen and you see the difference. In bus, all computers are connected to one main cable and all data passes through the main cable. That's where computers pick the data from. When it comes to star topology, all computers like this, like you're seeing here, and devices are connected to one central, here, there should be a central device, a central computer called what? A server, or a central device called a hub. So here is a central computer called what? Or what called a central server, a central server computer, or sometimes it might be a central what? A central networking device called what? Called a hub or a switch. Called a hub or a switch. Let me first make this more clear. There will either be a central computer called a server, or there will be a central device called a hub. What do I mean by that? All computers are connected to one central computer here, or one central device. All of them, like you're seeing these arrows. In this example we are having, we have how many computers? 1, 2, 3, 4, 5. And this should move away because it will confuse us. This should move away. It's supposed to be part of that. To confuse, to contradict what I'm explaining. You can move it away. So all computers are connected to one central computer or device. The computer can be called a hub. Then if it's a server, if it's a device, it can be a hub, or it can be what we call a switch. But it must be at the center where all computers are connected. How many computers we have in this example? We have 1, 2, 3, 4, 5 computers. Plus how many devices? We have this printer and this printer. So altogether, we have 5 computers and 2 printers, which means we're having 7 devices that are using the computer network. But all of them are connected to one central computer or device in the middle here. Now, how does this kind of network work? When a computer is sending a message to another, for example, if this computer here wants to send a message to this printer, this one wants to send a message to this printer. This computer wants to use this printer to print. This computer will send its data to the central computer here or device. Then the central computer will forward it to the printer. See? So all data which is being sent on network must pass through the central computer or the central device before it reaches to the other device or computer where the data is supposed to go. So in a nutshell, with a topology, computers and devices are connected to one central computer or device. The central computer can be called a server. Then if it's a device, it can be called a hub or a switch. Then all messages that are sent on the network must first be sent to the central device or central computer. The central computer forwards the data or messages to the other computers or devices. Now that one there causes a disadvantage. Why? If the central device, for example here, stops working, let's assume this device here or server breaks down. It means now there's no communication that can be done. Why? Because the messages can't be sent from one computer to another. Why? Because they must pass through this central device and so it's supposed to forward them to the other computers. So if this one dies, the central device or server dies, it means computers cannot send data to other computers or devices. So it means the network, the communication relies on the central computer. If it's not working, no communication can be done. That's one disadvantage. Another disadvantage is that it becomes expensive because it requires many cables, like you're seeing. Yeah? It requires many connections. So that one makes it more expensive. Then it also makes it more expensive because it needs a central device or a central computer called what? A server. With the bus topology here, even if there's no server, the network can work. But here, we need the server for communication, whether you like it or not. Now that one means it creates what? Another expense of having to buy what? The central computer or device. So if you had like 7 devices like we have here, you must buy an extra central device or server. That makes it more what? Expensive. Another disadvantage is that the performance of the computers depend on the performance of the central device or server. If the central device is not working properly, then the network will never work properly. That's a disadvantage. That the performance relies on the way the central device or central computer called the server works. Advantages. If one computer stops working, the network still works. That's one advantage. Then secondly, since all communication passes through the central device or central computer called the server, it means that the network can be more safe. Why? Because all the messages will first of all be checked by the central server. They will be inspected if they are good or bad. So we can install a firewall here. We have a software called a firewall, which can check whether messages are good or bad. So it can be installed on the central server or device. Then it can check the messages. So that one makes the topology more secure. Then another advantage is that since we have a central computer device, means that computers don't have to use a lot of storage space, their own storage space. Why? Because they can keep their files on the server. So files can be kept in a central place, which makes it what? Which makes it easy actually which makes it cheaper. Why? Because you don't have to have a lot of storage space on these computers. Then secondly, it makes it easier for computers to access what? Files and data, because they're in a central place. Another topology that we have, the more advantages here, let me just display them. You pause the video and copy them. All these are advantages. You get them on your own later. They're all here. You just have to pause the video and copy them. They're saying here another advantage is that no disruptions on the network when connecting and removing devices. Yes, I can just remove this device without even affecting the network. You see? When I remove this device, no problem. Network still works. So it is easy to disconnect what? Computers and devices. We have what called the mesh topology. Mesh topology, we say that with the mesh topology, what happens is that here, each computer must connect directly to one another. In these other topologies we had, computers don't connect directly to one another. No, they must go through a central device, a central computer for the star topology. For the bus topology, they must connect first to the main cable. But with the mesh topology, computers connect directly to one another, like you're seeing here, directly. So each computer must have a connection to the other computers. How many computers we have here? We have 1, 2, 3, 4, 5, 6. We have 6 computers, and each of those computers must have a connection to the other 5. That's why you're seeing these orange lines. That this computer is connected to this one, to this one, to this one, to this one. So each computer has a direct connection to all the other computers. Now, what's the disadvantage for that? Obviously, number one, the connections are so many, which means it makes it very expensive, because there are so many connections to be made on such what? A network. So many connections. Then secondly, the connections of setting up the network is very difficult. Why? Because there are so many connections. You'll have to do so many connections, connect so many things. This one you're connecting 5 times, this one 5 times, this one. So you see, so since there are so many connections that need to be done, it makes it very difficult to set up the network. Which other disadvantages there? Do you have any? You find up, let me see. I began with disadvantages. So they're all here. You just need to pause the video, and also I'm going to send the notes on your email. You get them directly and print them. Advantages for mesh. Do you have any advantages? Definitely yes. Why? If you compare the mesh and the star, with the mesh, the computers connect directly to one another, which means that computers are able to communicate or send data to the other computers directly, without first of all passing through a central device or computer, or without first passing through a central cable or a main cable. Now, this one makes communication faster for the mesh topology, because the computers just send the data directly to the other computers. There's some other advantages here, which I am sure they're very clear because I explained them well. You get them. I know they're very clear. They're all there. Failure of one computer does not affect the performance of the network, which means if one computer gets spoiled, network can still work. So there you are. All the points are there. You just need to pause the video and get them. We have the hybrid topology. Now with the hybrid topology, what happens here? You have to connect different topologies together. For example, here, you have the star topology, we have the star, but you can connect them together. And we have the bus here. So you connect, you can create a network by connecting many other kinds of networks. That creates what's called the hybrid topology. This is where different topologies can be combined. For example, star topology combined with bus topology. That's what called a hybrid topology. Obviously, now here, this one disadvantage is that it is difficult to set up because connecting each topology to another might be very difficult. You need to do a lot of work there. The configurations are not so simple. That is one thing. Obviously, it will be very difficult to design such a network, or to set up such a network. These ones are very easy to set up. Bus, very easy. Just connect the computers to one main cable. Star, very easy. Connect them to one central device called the server we have. Mesh, connect them to one another. But when it comes to hybrid, you're connecting different networks to another, network topology to another. You must plan a lot in this case. So it means setting it up becomes very difficult. Setting up hybrid topology becomes difficult. And even designing it, you see, designing means planning how you're going to connect, becomes very difficult. Then maintenance also becomes difficult. Maintenance is what? There's a lot of maintenance required. Why? Because we're having different networks joined together. So maintenance and troubleshooting. And troubleshooting the what? Network is very, very difficult. Advantages are there that in case the problems met by one topology can be solved by another. There are very many of them. You get them by own, but they're direct. I'm sure they're very clear. Let me just display them. So those are the types of topologies that you need to learn at this stage of year 12. One advantage for hybrid, they're saying it's scalable. Scalable means the network can be adjusted. So that is the end of topology. Now next.